Section 7.4, mass percent composition empirical formulas. After you're done with this video, go on over and look at the video problems 31 through 35. Quite a few problems here because you'll need lots of examples. So the mass percent composition or mass percent is the same way you would calculate any percent. So for example, if we have something like, let's do a good one here. Let's do something like, let's do calcium nitrate, CaNO3 2. Right, so if you want to know the mass percent of oxygen, so what's the percentage of oxygen? It's going to be 6 times the molar mass of oxygen over the molar mass of calcium nitrate, CaNO3 2. So it's always a part, in this case oxygen, over a whole, in this case calcium nitrate. Okay, so that's the mass percent composition. Now, we can use that mass percent composition to calculate what's called an empirical formula. An empirical formula shows you the lowest whole number ratio of atoms in a compound. In other words, here, take a look. Here's C6H6, which is benzene. Well, that can be smaller, right? That can be, over here, CH. So CH is the empirical formula. C6H6 is what's called the molecular formula, which we'll talk about here in a second. Now, there's 2 different ways to figure out the empirical formula, but what's important here is to know what this formula shows you. This formula, this CH, shows you that there is 1 mole of carbon for every 1 mole of hydrogen. Now compare that with NH3. NH3 shows you that there's 1 mole of hydrogen for every, or pardon me, 1 mole of nitrogen for every 3 moles of hydrogen. So it's a mole to mole ratio that you got going on there. So if we want to figure out the empirical formula of something, eventually we have to get it into a mole ratio. Right? And an empirical formula is the smallest whole number mole ratio. So if we start out with grams, we're going to first convert that to moles. So we're going to do a grams to moles conversion, just like you saw in the last section. And then we're going to divide through by the smallest number of moles. And that's going to be our mole to mole ratio. That's if we're given grams. Okay? If we are given percent composition, it's not too different. The only thing you have to do is you have to convert your percent to grams. And what you're really doing is you're saying, okay, if I have 100 grams of the compound, right, then how many grams do I have of each element? Then once you have grams, you're again going to convert to moles, and then you're going to divide through by the smallest number of moles. Okay, and once you go through some of the video problems, I think you'll be okay. Empirical formula is very important. You'll use it the rest of the year, and you'll use it a lot in AP chemistry as well. A lot of kids tend to forget it, so make sure that you have that. Now, once we have the mass percent, and you know this really belongs more in the percent composition section, but your textbook puts it in here. What you need to know is that percent composition is always true. So here is the percent by mass. Pause it. Hold on a second. Okay, so I had to wait. There was some noise in the background. So the percent composition, that's true for any amount of the compound. And so let me show you here what they have. So here's the percent composition of hydrogen, and here's the percent composition of carbon. Now, if I have 25 grams of methane, so here's CH4, which is methane, that means I have 6.28 grams of hydrogen, which is 25.1%, and I have 18.7 grams, or 74.9%. Okay, so what you can do with this, and this is very useful too, and a lot of students forget this oftentimes, is you can take the percent composition, multiply it by the mass of the compound, and then from that you can get the mass of that element. So let's say I have 7.93 grams of CH4, and I want to know how much carbon will this give off? Well, it's 74.9% carbon, and if this is the only source of carbon, then I'm going to take my 7.93 grams times 0.749, and that's going to give me my grams of carbon. So let me grab my calculator here. So I got 7.93 times 0.749, and that is about 5.94. Thank you, calendar. You can leave now. Maybe not. All right. That is 5.94 grams of carbon. So if I perform a chemical reaction with this much CH4, I will get this much carbon out of it, which is a pretty useful thing to know. And again, that's percent composition by mass. By mass, very important. Okay, so come back to empirical formula. Like I said, that little section there is sort of out of nowhere. But sometimes with empirical formulas, you will get not a whole number for the mole-to-mole ratio, for the moles. Okay, so maybe you'll get something like, and this is just completely made up, maybe you'll get 1 carbon, right? And then you get 0.33 hydrogens and 1 oxygen or something like that. Well, we can't have 0.33 of hydrogen. So what we'd have to do is we'd have to multiply this whole thing times 3 so that we would get C3H1O3, which is a made-up compound, but you sort of get the idea. Here's the important point. You cannot round between 0.1 and 0.9. So what I often say is if the mole ratio is below 0.1, so in other words it's like 0.04, right, or 0.03, then you can round those to 0. Yeah. Okay. Now, if the mole ratio is above 0.9, so 0.92, 0.95, something like that, you can round that up to the next number. Okay, which in this case would be 1, but that's what you get. If it's anything between 0.1 and 0.9, you have to multiply it by something. And you'll see an example problem like this on the video problems.